Hey everyone, and welcome to the Bricks, Bucks, and Bytes podcast, your weekly dive into funding, market, and investor news in architecture, engineering, construction, and supply chain. Before we get started though, if you're a startup founder or operator responsible for innovation in your company, or you want a deeper, more insightful look into technology in AEC, you won't want to miss our newsletter. From deep dives into particular technologies such as AI, robotics, design, software, and so on. Hot takes from investors betting big in AEC technology and advice on building tech companies, including the stories and takeaways of the most successful AEC technology founders. Head over to www.bricks-bytes.com and sign up today to get this exclusive material straight to your inbox. And now for the episode.
So welcome everyone to Bricks, Bucks and Bytes, where Patric, Hellerman and us usually discuss the latest funding and market news in AEC tech. So today we have very special guests, our host of Bit Builders podcast, Gabriele Tinelli, and also investor in Fundamental. Hello Patric, hello Gabriele, how are you?
Morning guys.
Awesome to be here.
Very good. So Owen is not this week with us. He's resting with his family in sunny Mallorca, I believe. So we'll have him next week.
I didn't know that Owen had a German passport. Or like, how did they let him get into Mallorca?
No, he's not in Thailand.
I don't know. But Mallorca is like the 17th federal state, is what the Germans say.
I think Germans and Brits are pretty much all over the world, here and there. So,
okay.
Yeah, that's my vibe. Gabe, what do you think? Are they covering Italy as well?
I mean, I found an Italian that I found a guy from my same 20,000 people town the day I landed in Sydney, Australia. I was like, this is not possible. So
what?
I think the capillarity of Italians is also remarkable. So I don't know if we want to get into a contest, but
I don't want to calculate those odds. That is crazy. But where do Italians actually go for holiday? I mean, you have such a beautiful country in the first place.
Exactly. Well, that's the first one. So I think the first country for tourism from Italians is Italy, and then I think a lot of people go to Greece just because they want to change the side of the Mediterranean, but that's about it. Otherwise, we're very mountain driven in tourism. So you'll see them in Austria, Switzerland, France, the very neighboring stuff. We don't, fly to an island because we have a few. That's
and by Austria, you mean nowadays Austria, not the part of Italy that used to be Austria.
Yeah. Of course.
Okay.
Beyond Fiume, which is like the line.
Okay.
Very good. So maybe before we dive into today's topic, Gabe, maybe you can give us a flavor of what Bit Builders podcast is. You interviewed, I think four founders, and not only founders in the industry. So give us a flavor and maybe what future guests you're thinking of.
Yeah. Well, Bit Builders is something fairly new. Only 4 episodes came out. The idea behind Bit Builders is talking about people that are building hard things, and it happens to coincide a lot with construction robotics, but there's also other interesting stuff. I've been interviewing people that I think are at the forefront of robotics and traditional industries together. So people like Gecko Robotics, Drone Deploy have been leading the charge in drones and robotics for traditional industries, but also it's coming up now, so it's a bit of a spoiler. But one of the founders of SpaceX is coming on. Dusty Robotics is coming on. We're having a bunch of people.
Oh, you have Tessa on from Dusty.
I have Tessa from Dusty.
Wow.
And we're also going to dive into something that's more early stage, that it's really promising and category creator. So we want to have diversity, but the goal is creating a knowledge pool for founders that are building in the space, and not only anyone that's interested, but it's coming along pretty well.
Very good.
So what gave you the right to talk about robotics, Gabe?
Exactly. I wanted to ask about your background.
Well, I don't feel the right to talk about it, but I feel that I can. Meaning, I'm an aerospace engineer by background. I worked in a bunch of robotics projects before at the interface between university projects and then spin-outs. And I actually started with with the underwater robot project in high school. A robot that had to hop the abyss, like the bottom of the ocean floor, so that it could explore shipwrecks. So that was my first approach to robotics.
No kidding.
Yeah, but then then did my master's in applied math. I hated it, dropped that, and then went to work for about a year for a space tech company that's based out of Colorado. It's called Think Orbital. And by the way, by complete chance, they're building in space. So they're the first, I think, construction technology startup that's operating in space. And they just recently demonstrated welding. So electron beam welding in space, which is basically the key unlock to building large structures.
Without oxygen.
Yeah.
Just for everyone to understand the
You need
implication here.
Exactly.
Yeah,
and
beautiful.
I'm actually getting the CEO on BitBuilders soon. So stay tuned on that.
That's
Wow.
super technically interesting as well. How can you weld without oxygen?
Well, you can basically heat enough to surfaces with a beam of electrons, which is very efficient to do in the vacuum. So actually, electron beam welding is not a new technique. It is used on Earth, but it's a very inefficient technique if you don't do it in a vacuum chamber, and it is a very efficient technique if you do it in a vacuum chamber. Now, if you look at the energy flows to power the vacuum chamber and to do electron beam welding, it's not a power efficient thing to do on Earth, but it's the most power efficient thing to do outside of Earth. So that's why they're using this one. And the story with that technology is that basically the Russians tried to use it, and they did indeed, like it was successful, outside of the space station Mir, which is the father of the ISS. Now, I don't remember exactly the year. I think it was before 2000 or just after the new millennium. But they used a machine that was a handheld to electron beam weld, and they punched a hole into the station by mistake. And luckily, it wasn't on the life support part of the station, so they didn't die. But it was a harsh one. So they're trying to make that robotic because it's just safer.
I love it, Gabe. I already sense the nerdiness.
Yeah,
So
a lot of it. Very good. So we've got aerospace engineer turned VC, construction tech VC. We got Patric with us. So I think it's a right time to start talking about today's subject, which is actually convergence of all of these things. Starpath Robotics wants to mine moon water for rocket fuel for off-world colonies. So let me just intro briefly what this announcement says, and I will hand it over to you guys for comments. So Starpath Robotics has emerged from stealth with an ambitious plan to design, launch, and operate machines to mine and refine water for rocket propellant using resources on the moon Mars. In situ resource utilization of water for the purposes of making rocket propellant is not a new idea. Rocket propellant is a mix of liquid oxygen and some other combustible fuel like hydrogen, kerosene, methane. Given that there's plenty of water on the surface of the moon and Mars, people have long speculated that these resources could be put forward, making propellant in space and building a self-sustaining human colony of the world. So does it sound like a substantial cost to found a to found a company, or what are your thoughts, guys, on this?
Gabe, you go.
Hey listeners, I want to take a quick break to remind you about the Bricks and Bytes newsletter. If you're interested in learning about the technology shaping the future of construction, you won't want to miss the valuable insights we share each week. To get this exclusive content delivered straight to your inbox, head over to www.bricks-bytes.com and sign up today. Link is in the show notes. Back to the show.
So this is a piece of necessary technology to make life multiplanetary. That's for sure. That's kind of like why this announcement is having a lot of resonance in the aerospace community. I think the key there is in situ resource utilization, ISRU. The entire principle is we can't go off our planet and bring our stuff with us, and make life possible there. We gotta use resources that we find on other planets. First the moon, just easier, closer, and then later Mars, because it's more doable. There's somewhat of an atmosphere, a decent gravity force that can help us basically move around in a more Earth-like way. but it's far. It's pretty far. So we're starting with the moon. And a lot of people have been trying to think, how do we use lunar regolith? So basically dirt and stone that you find on the moon to make stuff, to make habitats, to make shelter. And also there's thoughts on how to make fuel. I don't think they're very far yet. And then what the other thing that you have is dirt, icy dirt. So basically this pre-icy, there's like ice that's covered in dirt that you need to heat up and separate, and it becomes water. And that's another resource that we can use. Yeah, I think it's super interesting technology. Happy to go in detail, but yeah.
So I'm not a space nerd as you are. My amount of space knowledge stems from 3 times binging For All Mankind, which is a series I can highly recommend for anyone. It's on Apple TV. Just quick anecdote. So the series starts in 1969 in an alternative universe where the Russians were the Soviets specifically were the first on the moon, and not the Americans. And then how would have life unfolded over, I think, currently 4 seasons? There might be a 5th one in production. How would have life unfolded? And you know, it goes into politics, it goes into society, but it goes into technology. And so what I found fascinating, and I'm going to come with a question here, Gabe. What I found fascinating is how it unfolds that, you know, colonization of moon would have started in the 70s. Colonization of Mars in that series would have started, I believe, in the 2000s. And they use moon as for two reasons. So one, in order to be a launch pad to Mars that is more efficient, and 2, to actually mine helium-3 as a propellant for space flight into Mars, as well as for colony on Moon. Eventually, they actually go, I think, with some nuclear engine to reach Mars in that series, whatever. But that's my question. So why are we caring about building on Moon? Like, what is it for? Launching interplanetary colonization in a more efficient way? Is it that it's actually a good colony to be in the first place? Like, what is your thoughts here?
So depending who you ask, the moon is seen as a testing ground for Mars. So you have basically, this is the first extraplanetary, so the first, you know, out of Earth environment that is real life. It's harsh in its conditions. Remember, it's like negative 180 to 100 degrees. So that's
extreme radiation.
Yes, and extreme radiation. So no atmosphere to protect you. You have to be sheltered at all times with technology. So depending when you ask, the moon is seen as a stepping stone to get to Mars, because we have to refine the way we move around, the way we refuel our ships, the way we provide life support to our astronauts. If you assume that you want to launch humans, it's not an obvious thing, but if you assume you want to launch humans, you want to refine life support. You also want to refine communications, which is hard as hell. There's a company out of Italy, it's called, oh my God, it's evading me, Orgotech, that is basically creating a constellation of satellites on the moon to basically have internet on the moon, because it's not an obvious thing, and relate back to Earth. So basically we have to refine all of this. And so the moon is basically our playground to understand Mars. In addition to that, there's a lot of research that we have not done, because the moment that you have mentioned in For All Mankind, you know, it happened in reverse. The US went there first, the Soviets went bankrupt with that space program, and then the US were like, all right, we'll launch another 5 missions to the moon. We'll collect some samples, but that's it. And since then, Saturn V hasn't.
That has been 55 years.
Yeah, and we haven't been on the moon. But one might ask why. Like, why haven't we done it? Because it's so expensive, and it was so expensive until just recently. SpaceX made spaceflight cheaper, and a bunch of other things came into play, so that the entire mission is cheaper and safer. So we're using the moon because of that, and also because there's a lot of research away from Earth, from the Earth system, so moon orbiting the Earth. It's basically so much easier to do if you start doing it from the moon. So you can put telescopes there. They are not gigantic like James Webb. They're really difficult to handle like James Webb, and you can build them on the moon. So yeah, so that's the idea. And keep in mind that James Webb telescope is so much behind current technology that we can build, despite being the best, because it has to sustain so many radiation and vibration to get in orbit to the Lagrange point L2, that we're good at making telescopes. We're not good at making vibration resistant materials.
Interesting.
And so that's another piece of it. Yeah. So that's the idea. That's why we're on Mars. Why we're on the moon soon, and that's us testing ground from Mars.
Okay, so do you guys see there's more and more startups trying to get into the space, really? Because just reading a little bit about this one, I've noticed that which I completely ignored in the past. There's like so many startups working on like solar batteries and some other stuff. So is this now like a large portion of venture capital funding that will be going into the space, or that has been going on for a while now, and it's going on its own path? What do you think?
I believe the stage is well set. As taking back what you were saying, Patrick, because we cut since 1981. I think 1981 we had $85,000 per kilogram of launch. So if you want to launch one kilogram,
can you repeat that? 99? No?
So if you wanted to launch 1 kilogram of stuff into low Earth orbit with the space shuttle, which was the vehicle of choice back then, in 1981 you had to spend something like $85,000 per kilogram. Imagine that is usually measured in space shuttle. I think could carry above 3 or 4 tons of useful payload. So that's a lot of money. In 2022, I think SpaceX broke the ceiling of $700 per kilogram.
Oh.
So it's basically less than 1% of what it used to be, the cost of launch. So we have solved that, right? I would say that we have, because if you take basically how many companies can now benefit from that payload launch, the subset is enlarged by the same factor as as the reverse of the cost reduction. So basically you have 100 times more companies, 100 times more business models that are potentially enabled by this. There's a huge but to this, which is you need to build satellites, and satellites are not cheap to build for now. You need to build them radiation resistant. You need to build them vibration resistant. You need to have hardware that is really difficult to cut costs for, like communication hardware from low Earth orbit to Earth. And you need to make them do something, because then you have a piece of hardware in space, but you don't really know what to do with it. So there's a bunch of different options. There's pharma research that is a pretty promising one. And there are advances in Earth observation, which I really want to talk about, but I think I'll save them for later. On pharma, I think right now this is the most interesting business model that we can find, because what is this is manufacturing in space. I think we need to step back on why do we need to manufacture some drugs in space. A lot of drugs that are on the market now are created by protein crystallization. So basically making the amino acids, the single components of the protein, structure into a 3D structure, which is basically becomes a protein. And that requires a lot of energy on Earth. And one of the reasons why is that the molecules tend to collapse on themselves. If you're in space, it's pretty logical. You don't have that force. So the protein crystallization can happen in a more organic way, and in theory, at scale, you can produce in a much cheaper way. And then in the lab environment, you can produce stuff that you could never produce here. Stuff that basically it's so light that would collapse on itself. And one example is retinas. If you want to make artificial retinas, Lambda Vision, I believe the company is called, they launched a bunch of research missions to the ISS. They will create the first space-grown retinas, which is a product that will never be able to exist on Earth, created on Earth, because it's too light on it. It's too heavy, but too light at the same time. So it's too dense and basically collapses on itself if gravity is there, until you have a form structure, and then you can ship them back to Earth. And regain and give vision back to people that have retina problems. So that's one huge part of the market where I really see an earthbound market for a space-made product.
That is
And
fascinating.
then that's my mental model. But then a bunch of other things will not work.
Sorry, I just want to tie it back to construction, Gabe, and then giving Mike back to you. That
Yes.
means that we need to construct labs or factories
Yes.
outside of Earth, right?
Yes.
And so for that, unfortunately, or ideally, we don't have to have the logistics or the supply chain to actually carry, even with $700 per kilogram payload. That is still very, very expensive to carry, to basically pre-manufacture on Earth and then carry it outside of Earth, right? So how do we construct these environments in a super capital efficient way, especially cutting the cost of logistics?
Yeah, and that's the key problem.
If I can add to this, actually, so is the technology that engineers in the aerospace are working on, is it coming in terms of building these facilities, perhaps, or trying to think about building these facilities? Is it in any way coming from construction or construction technology, or they are in the space thinking or are on the forefront of technology, and then what's kind of left goes into construction technology, perhaps? What's the dynamics here?
Well, I think the philosophy comes from construction technology here, meaning let's call it real estate in space, because that's what it is. Enclosed space that you can potentially put something in outside of the Earth's atmosphere. What's our real estate in space right now? I mean, we all know that the entirety of humanity is now living on Earth, except, I don't know, what is it, Patrick, 6 or 7 people that are now in ISS. I don't know. So you have 6 or 7 people that are living in the only piece of real estate that we have outside of Earth on the ISS. There's also the Chinese space station, by the way, which just came to mind. But the idea is you have the only place where people can be. It's 400 cubic meters outside of space, and we launched that with 27 missions. It took a gigantic effort of over $100 billion over a span of 20 years to build only 400 cubic meters of space in space, right? How's that coming together now? What are our thoughts now, or the company's thoughts and the scientists' thoughts, is to borrow concepts from modular construction. So you can basically build pieces of that habitat and assemble them in space. Because the cute thing here is there's always caveats with space. There's always buts, right? We have solved up mass to low Earth orbit. So we can ship stuff cheaply. What we haven't solved is volume. Basically, the payload fairing is always the same size. So the maximum, metal tube that you're gonna be able to ship on to low Earth orbit, it's always the same size. It's limited by the size of the rocket. So what do you do there? You stack panels one on top of each other, and then a robotic arm assembles and welds them. That's Think Orbital's vision. And there's many other models out there. There's gravity.
I want to double down on that. So the difference between mass and volume is very important in logistics for constructing in space. So I'll give the example of a company I talked to. It was probably a year ago. It might have been early this year. And tying it actually to your point about building satellites. So that company is building a technology that actually prints satellites and the satellite arms, as well as the satellite power source, entirely in space. So it starts with just let's say a core, a nucleus of the satellite, which is a 3D printer, as well as all the material that is required for printing. And then the company has built the technology so that from there, all the arms, the sails, etc., that you would need for any structure that you can print, be it a satellite, be it a solar sail, etc., would be printed from the nucleus out. And so I asked the company, hey, but in the end, you're going to have the same mass as if you just pre-built it here. And they explained to me, well, that is actually not the problem anymore. The problem is actually the volume in the rocket. So right now, if I wanted to reconstruct the exact same thing in space, I would need probably multiple trips in order to have enough space for the volume that you need for these massive arms, etc. And then I would need to assemble them in space. While we are condensing all of that into one basically point, and then allow that to be carried on one payload. And so for us, hey Gabe, So for us, the problem of volume versus mass seems to be volume right now. Sorry, Gabe, I don't know if you caught all of the explanation of the company.
I did remember the company you were talking about, but at some point,
Yeah.
My router just decided that I wasn't worth the conversation.
Yeah, and so just to catch you up, right? So they were saying, hey, actually, so with our technology, we can make the trip in one space flight in instead of maybe 3, 5, or 7. So that's when I realized that the problem is volume, not mass.
And then what do you do with that volume, right? That's another question. What do you put in there? There's a queue of about 7 years to put your experiment on the ISS if you want to do it right now.
Oh, wow.
You can submit a paper.
Yep.
Right? You can say, okay, this is my paper, breakthrough in biology. This is awesome. You got to make me experiment it. It's like, yeah, that's awesome. Okay, see you in 2031. Except the ISS is going to be decommissioned in 2030. So basically, we are out of spots to experiment on the ISS. So we need more real estate in space. So there's a bunch of companies like Robotics, Think Orbital, Vast. They're working with respectively SpaceX, Boeing, and other players, also Blue Origin, to make this a reality, to make new real estate in space. Varda was one that Founders Fund was funding that had really make deadlines because it couldn't fly back into Earth. It couldn't get the FAA authorization to basically become a comet and just plummet on Earth on fire because they had, I don't remember if there was an electrical problem on the design or whatever. They couldn't do it safely. So there's another point there, is making the logistics work to make stuff come back on Earth. Because we've talked about what it takes to go up, but we haven't talked about what it takes to go down. And that's a volume problem again, because it's a cheap thing to put a heat shield on something and make it fly through the atmosphere. But it's not cheap to have literally just a truck, like a re-entry vehicle filled up with stuff that you have to go down. Like who gets there?
So now I have a question for you.
Yeah.
So being the For All Mankind fanboy and amateur fanboy that I am. So in the series, Dev ISI is this huge space economy entrepreneur, right? Billionaire, intelligent whiz kid. And so after, I think in the series, 25 years after man stepped foot on the moon, he actually had a massive spaceship. Was it inside or outside of Earth's orbit?
Yes.
And so it had this artificial gravity. It was basically rotating around an axis to create a massive ship. How did he actually construct that outside of Earth? Was there like this? If I remember correctly, was there this dozens of kilometers long elevator to ship stuff into space? Was that the secret that he
Yes.
took in the fictional series?
Yeah,
That probably wouldn't work now.
Yeah,
in
that's
real
the
life.
sci-fi holy grail of space. It's the space elevator. So the space elevator is a concept that we don't know if it's viable, by the way. I don't think there's any conclusive research that says that it's possible. But potentially, you can run a super long cable from here to low Earth orbit. You'd have to think about how doesn't that cable collapse under its own weight? How do you direction it? It's just a mess, right? But you can tie stuff to that cable and you can actuate some robotics on that cable to basically pull a payload from Earth to space and from space to Earth. That's the holy grail. That's basically the next zero that we're gonna carve out of that launch cost. If anything,
You think it's possible?
I don't think I can answer that. I think there's a bunch of papers that tell us it's possible. But they take like material densities that don't exist, right? So I can construct something that it's potentially possible, but if I'm using not real components, then is it possible? I don't know.
We'll see.
So that's the idea. That's the space elevator. The other option that we got is basically you send piece by piece bits of that giant spaceship, And at the same time, as the companies that you were describing are pioneering right now, you have robotics fleet that are basically printing pieces of the ship. So you have some of the construction that's happening on site, and some of the construction that's being prefab and shipped. That's exactly like would do in a super efficient construction site. So yeah, that's our chance.
Do you guys see that these companies which are creating robotics for the space are trying to create robotics on Earth, or these are completely different industries and they don't like penetrate each other within one company? They focus only on space or on construction on Earth.
There was a company, right, Patrick? We were talking about someone that was doing earthbound robotics that in the end was going to become for Mars. I don't remember the name, but in general, yes, I think Orbital's plan when we weren't able to raise a pre-seed for a few months was all right. Let's make the best electron beam welding gun and just sell it on Earth. So I think there's a lot of application of space designed for space hardware that you can use on Earth at the highest performance. I mean that's the story of computing, right? That's how we got computing. You can design for extreme temperatures, extreme environments, and then use on Earth with like it's like a kid's playground. It becomes a kid's playground to operate on Earth. So some of these companies probably to survive will have to build top-notch robotics on Earth, sell it on Earth, and at the same time grab the first contracts with NASA, with ESA, with the Air Force, and try to break into the space, in the space of space tech. Some of them will not. I think some of them will straight up go for the candy and be and try to be the leading provider or whatever they're building directly in space. But that's a risky business model. Both of them are, but this is the riskiest that you can get.
So guys, I think the companies that might sort of start with technology on Earth and then have the ability to transfer it outside of Earth will be companies that, one, will have technology that is either independent or somewhat resistant to the extreme conditions that we encounter outside of Earth for whatever reason. And two, that are ideally independent from supply chains. So the example that Gabe you had in mind was a company that was building a rover for the moon, and they had certain technology components that they were able to reuse from rovers that we would use in the Arctic or that we would use in deserts, right? And so, these are the most inhospitable places that we would find on Earth, though probably not comparable to the inhospitability that you would have on the moon, but it requires very little supply chain in the end. Of course, spare parts is a thing, but you wouldn't need to fuel it other than with, photovoltaic power. Whereas robotics arms, for example, are already different. So for your robotics arms, the robotic arm in itself is absolutely useless unless I feed it with material or components. So there you already have the supply chain component to it. So the less you have of this and the more resistant you are to inhospitable conditions, the more likely you will be to actually have, what you're asking, Martin, the ability to transfer technology from here to there. The more of the other two you have, the more you might have to design actually specifically for outside of Earth.
Mm-hmm. How would investors think about like return on investments, investing in like space tech or robotics companies that operate in the space? Because if we talk about construction, there is like this long sales cycle and the long, capitalization time from investment point of view, I guess, because of the sales cycle as well and how the construction works. Feels like in space, it's even much longer. There's not that much of a market. There's no, obviously, B2C customer in any shape or form. But how investors think about returns on those investments? Because it seems like a risky thing.
I think you can segment this. So space for Earth.
For example, on the example of Starpath, right? So a fleet of around 15 mining machines will drive around the surface on the moon and dig up massive quantities of dirt, right? So the product would be what? The water, right? In the end of the day.
It's the refueling service, I believe. I think the product that they will like the service that they will offer two companies like SpaceX and Blue Origin that will have the capability to fly and land on the moon. And by the way, just to think about returns, this doesn't exist yet. So you have to believe certain things to invest in these infrastructure plays. But basically, they will provide the infrastructure service of refueling on the moon. So it will basically enable SpaceX to go and explore the moon, land there, and know that that Starship, that vehicle, will be able to be refueled and come back to Earth. So it's basically feeding into the business plan and the idea that SpaceX has of reusability. But I think when investors look at space tech, there's a bunch of different bets that you can make. A few bets in space would have been super smart. And one of them was obviously SpaceX, but let's take that out because it's too easy. Another one is a company that few people know that's called D-Orbit. It's a company out of Italy. It's a unicorn now, D/Orbit. And what they do is they provide in-space logistics. So vehicles of orbital transfer from one orbit to the other. They provide refueling vehicles. They provide taxis. They basically detach from the rocket and spread out satellites. This is the type of bet that you would underwrite as an investor if you believe that the space industry as a whole is growing, is that the number of satellites that would be launched will grow in the future, and you want to be there helping that. Yeah.
It's not the first time in mankind's history that we're off to new shores, and I'm using that term deliberately, and developing a new economy and reaping massive benefits from it. The best investment in mankind's history that anyone could have ever made is actually not any time in the last 100 years. It was basically the East India Company. If you had invested in that company in the 1600s, you would have been in for a massive reward. And that was developing a new economy. So what we can learn from that is that one thing always repeats. As you find new, let's use Gabe's term, as you find new shores or new real estate to develop, you need to invest in one of two things, in my opinion, and that's exactly how mankind's off to new shores has always evolved. One, you need to invest in eliminating the need for a long supply chain. Eliminating the need for a long supply chain. I'll explain what I mean by that. And two, find, develop, manufacture, and bring home resources. That's the two things that have always worked in finding new shores, investing into it, and reaping massive profits. So I think finding, refining, manufacturing, and bringing home resources, I think that much is clear what I mean by that. So that's something I think you can invest in the space economy for sure. Two, or one, I should say, eliminate the supply chain. So investing in eliminate the long supply chain. Investing in a long supply chain, in the end, is actually still inefficient. The best supply chain is the one that you don't need. That's what logistics people will always tell you. The best supply chain is the one that you don't need. That's why, for example, on Earth, sustaining a war on a different continent is very, very expensive. But sustaining a war on your home turf is actually not as expensive by a large degree. And that is because the long supply chain is what exponentially drives costs, chaos, etc. So the best supply chain is the one that you don't need. And that's what you should invest in the space economy. And that's how, for example, Starpath is sitting, right? So we're refining fuel on Moon in order to eliminate the supply chain of having to carry fuel. So that makes sense. Now, the one thing, though, in the space economy that as an investor you will have to live with is, can I actually make a return before the companies run out of money? So do I get the timing and the fixed cost right until I can actually generate revenue? And that, in the history of mankind, is not easy to time, because you have to invest in the company that ideally, you have to invest in the company that can develop its own ecosystem abroad, far away, doesn't need any kind of supply chain, from home, and then abroad basically creates its own resources to sustain itself and brings those resources home. That's the company you want to invest in, because that's the company that will not need huge fixed cost, huge operating cost until you turn a revenue, but that will actually generate business from its own. So that's the company you should look for, in my opinion.
All right. So do you guys look into aerospace to any degree within your investments?
So construction tech in space, absolutely. So we invest. So you know what we always say is we invest in construction tech anywhere on planet Earth and outside. So we absolutely do that. However, we are looking at it from the perspective that I've just shared with you.
Cool. So maybe speaking about robotics, because obviously Starpath is a robotic startup actually. So should we touch on startups that you guys looked into and on the Earth, which deal with robotics?
Yeah, I mean,
Gabe, you're our resident robotics nerd. You have the Build Builders podcast. What kind of robotics companies do we like?
what kind of robotics companies do we like? Well, first of all, we don't have. We've been building a framework together, at the firm. I think we take a lot of time and reflection in analyzing the companies that we speak with, the founders that we talk to, or even people that are just thinking about building robotics. I think we want to invest, first of all, in construction robotics. We want to invest in companies that are building robots that, first of all, are augmenting existing workflows, so they're making existing workflows cheaper and faster. And we have a knack for investing in some of these that are suffering basically from very big labor shortages, or where workers are in danger. So we have a preference for robotics that has little friction to adopt, where if someone is coming to you with a robot, they're going to be starving for that solution. So that's definitely something that we like. We have an entire idea on what do we do. That's actually Patric's framework to an extent. So I'll let him half of that, but I'll to give half out. We are looking for companies that are serving the construction world with solutions on bidimensional surfaces that are uniform. I can give you a big example of that is roofing. Roofing is the most uniform and bidimensional surface that you can think of. Walls are the same, pavements are the same, and floors. And basically, we're looking for that because these make the perfect use case for a replicable workflow that a robot can perform without having much intelligence into it, without being extremely layered like a human can be and handling all edge cases. And then beyond that, we think that what's key for a robotics company is to target a workflow that has an actual P&L item. Otherwise, or at least it's it has a subcontracted P&L item, because in a construction project, you're not going to buy other than an outcome, most likely, unless you're a trade subcontractor and you're leasing a really useful machine for yourself. That's another way to look at robots that we take from our conversation with Builders. I'm happy to expand. But these are two of the pieces, and I see Patric that wants to get the rest of that. So
look, and by the way, there's new. So Martin, how often do we speak about nuance on here, right? So there is nuance to what you just said, Gabe, right? So what we're looking for as one element of our framework, and actually we're publishing the framework next week on AECVC. Check it out, aecvc.com. But one part of that framework that you're right now talking about, Gabe, is the relation or the ratio of large two-dimensional surface area to the corners and edges, right? And so that ratio, initially you might think, hey, I want that ratio to be super high, but actually there is too high. You definitely don't want it to be too small. So too small, for example, would be, let's say, a 50 square foot bathroom having to be tiled. That's not a very good ratio of two-dimensional surface area, homogeneous, two corners and edges. But you also don't want it to be too large, because when it's too large, then actually the use of labor might be exceptionally efficient without the use of robotics already today. We might already have machines for that. And the example, for example, is asphalting a highway of 12 kilometers. So building an autonomous robot for that is probably not actually a net ROI enterprise compared to the semi-autonomous or like human-controlled machines that we have today, because the labor cost per square centimeter is extremely low, right? So the ratio of two-dimensional surface area to corners and edges, that sweet spot is somewhere in the high but not very high range. Mm-hmm. So we have other parts of the framework that we're going to publish next week.
Mm-hmm. So when we think robotics, do all founders agree that outcome as a service is the way to go, or perhaps not necessarily, and those who don't have valid reasons for not agreeing with that?
Nothing in life is 100%, Martin. It's also not 100% here, but it's definitely more than 3 years ago, I would say. I don't know what your experience is, Gabe.
Yeah, I think a lot of robotics companies are trying different business models right now, and I've spoken with Tessa at Dusty Robotics. That's one example, and she didn't know what the business model could be at the beginning, so she tried a bunch of different ways. And there's other companies on the market that are, for example, automating solar construction that are addressing so many different stakeholders that the way of selling to them may vary even within the same workflow. So you might want to lease your machine as heavy equipment to someone, but you would also want to sell the outcome to another type of stakeholder. So I think there's a lot of nuances here, but I'm personally seeing more and more companies that are selling the outcome, or at least planning to sell the outcome. I think there's a bunch of the few success stories, or at least good takeoff stories that we have on construction robotics. I think they almost all center around this type of business model.
And keep in mind, I sometimes have the impression that people feel like whatever model they choose today is carved in stone for eternity.
Oh yeah.
And that's a perspective you shouldn't have as a founder. Your company evolves over time. How many times has IBM reinvented itself? Is it 3 times? Is it 4 times? Right? And so the ability of your company to evolve is what unlocks category creation. No category creator that I know of does on, let's say, day 3650, the exact same thing it does on day 365. And that is because, especially in construction, especially in AEC, the thing that truly scales oftentimes, and that allows you to scale, is track record. So the ability to actually build track record can unlock your ability to perhaps later find a different model in robotics that you like better. Perhaps at that point, you actually contemplate, hey, now selling the robots is feasible and is perhaps capturing more of my value because I have previously developed the track record of delivering the outcome as a service and guaranteeing the outcome. So whatever choice you make today, it does not box you in for choices that you can make in the future, how to differently monetize, as long as it comes with you developing track record.
Okay. What are the company, without obviously sharing any names, but what robotics company would you guys definitely not be looking at a potential investment?
Wait, do you want names? Because I don't think we'll give you any
names.
No.
I said no names. No, I don't
know. No names. Okay, no names. So companies that
keep it as an advice for founders, perhaps not to pitch you better, but to prepare better products or services.
I'll give one example, and Gabe, perhaps you can give another one. So for me, a company that pitches me with a very strong mindset of automating everything, I will not look at it. It might work, but it might not be capital efficient, and it definitely wouldn't have the highest customer ROI.
By the way, I will shift the subject completely, but recently I was visiting Poland, and there was this hot dog robot in this small chain shop called Żabka, and the robot took like 1/5 of the space of the whole shop. A gigantic robot creating hot dogs. So I think I don't know how was the ROI on this for them, but didn't feel like it fits there well.
You know, the pitch deck of that company doing that on slide 2 said, well, robots don't ask for a salary raise.
True. Yeah.
And don't unionize.
Probably, yeah.
I don't know, Mark. I think
because what I actually found on this example of that to maneuver the arm to like hand everything in the right order, it takes so much space to let the arm to maneuver to put all the things in order, which is actually interesting because in construction, unless it's there's this large ratio of space to corners, what you were Patrick talking about, it's much more difficult than to to fit a robot in a confined space or smaller space without as much volume to let the robot to do its job. Yeah?
Well, that's probably true, but it sounds like a controlled environment. So that is a good condition to start with for robotics, not necessarily to develop defensibility. That's on a different piece of paper, but to develop something in a more or less capital efficient way that will actually work. So that is a condition that you can consider, etc. So depending on how you look at the problem. Actually, Gabe, before you go back to Martin's earlier question, I just had like a question forming in my mind that I have never thought about. So the hot dog example that you're giving, I would classify that as a champagne problem. So a champagne problem being, dude, if mankind didn't have this problem, it would still survive and still procreate and still make interplanetary colonization. That's a champagne problem, right? And so I wonder whether actually for a robotics company, should you go first after champagne problems or first after non-champagne problems? I've never thought about it that way. I don't know.
Well, the beauty of this is that if the champagne problem can make you revenue fast and get you out of the woods and prepare for the wider problem, you're gonna be able to basically have maybe slightly lower margin on, but still very healthy. I think champagne problems.
So the car wash robot for my Bugatti car. You think that's a good way to start your robotics company? I've never thought about it. I don't know. I mean, I only have the Lego version up here, but what do they cost? Like $1 million, 2, 3, something like that. I mean, what's among friends to actually purchase from the Bugatti dealer, then also for 300,000 the car wash robot?
Maybe in that case, the car wash will be custom to this car only, and you could charge 20 grand to wash it in a certain way.
So does that unlock me that I now get from that experience this track record, and from that experience I get to then develop the cheaper version for the more everyday car? Is that like a good start starting with a champagne problem? What do you guys think? And that's actually interesting. So in terms of robotics, I would. So in the framework that we're publishing next week is we're actually advocating for founders not to think of TAM in your first iteration of your product. Do not think of it. It will actually lead you to try to automate everything. It will lead you into competition very, very quickly, but try to go hyper narrow and in a capital efficient, high ROI way. It allows you to build the hardware component inventory. It allows you to build the software inventory. It allows you to earn track record. It allows you to build team, etc. And actually this champagne example that we're giving, I mean, what's the TAM of a Bugatti specific car wash robot? 3 million. That might be the TAM that literally you would be having, right? But it doesn't matter if those 3 million actually finance the development of that and you get insane track record and you perhaps even get distribution access the way you said. That's the way how to break into a market in robotics and AC.
Interesting. My thoughts on this is specialization works, and if you can show that you can provide a service or your product deals with particular problem for particular type of person or customer, then it's a beautiful business model. So I don't know, but it feels to me that specialization is the key to success, at least with traditional business. Well, initially, yeah. So, but then when you start grabbing these verticals, yeah. Guys, depends how much time you got. I've got potential 2 subjects that I want to touch on. One is the kind of quick one. Revenues of construction robotics companies, and another one is a corporate view on robotics and perhaps adoption that you could have met in your journey when assessing and speaking to robotic founders. So which one should we touch on?
Let's start with the second one. So I think for us, the adoption willingness and the adoption ability of incumbents for robotics has exponentially changed the last 3 years. And I think it has to do with 2 things. One, the flight of qualified labor has exponentially changed and is about to further inflect over the next years. And 2, sectors undergo what we call the waves thesis. So what the waves thesis, our waves thesis says is that every era of technology, construction technology specifically, you lay foundations for the next era of construction technology. And that foundation is there's a technological element to it, but mostly there's actually an element of building infrastructure within the industry to adopt more and more technology and customer readiness to adopt more and more technology. It is the culture, it is the behaviors, it is the mindset, it is the teams, the organizations that actually through every era of new technology get prepared better for the next era. And that's how industries and sectors actually reach over time, after a very, 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 very painfully slow adoption curve, it reaches inflection. And we're right now at the next era of construction technology, and that is evidenced by the ability of, the willingness of construction incumbents to adopt technology. It is changing in front of our eyes the last 3 years. I would say in the US it is changing. I would say in Europe the supply of robotics is the greatest in the supply of talented robotics teams for construction is the best in the world. But the customer adoption is maybe a year, 1.5 behind the US. And even in India, that is changing, which historically, when you talk to the local ecosystem, we have cheap labor and, or inexpensive labor and it works. No, but the problem is they have 70 million construction workers. Many of them are not qualified enough to actually help with the amount of construction that India is undergoing over the next decade. So they actually need to either train 70 million construction workers to have the quality level that they want, or the qualification level that they want, which is a much more massive enterprise actually than implementing robotics. And we're even seeing that in India right now. So it's changing in front of our eyes.
Brilliant. How founders are looking at revenues within robotics startups? I think, Gabe, you mentioned maybe 15, 20 minutes ago when describing one of those. It's definitely not as quick as SaaS, okay, but also from investors' point of view, how do you guys see path to any sort of revenue for robotics startup?
I'll go quick and then I'll let Gabe. So we're seeing all colors, all flavors, how founders are approaching it. However, we have a certain taste for founders that have more of a software mindset to building robotics and have a background in engineering complex software, and who do not have a background in automation, for example. And the reason is exactly that. The path to revenue is quicker if you actually develop an engine, dev processes to your company that is built on iterating every day. And then iterating every day, bringing that into also a live environment, and that live environment comes with certain type of revenue. Now, it might not be the quality of revenue that you're looking for. It might not be the repeatability of revenue that you're looking for, but it is revenue proven in the real market. And that only comes if you build your company with a very specific complex software type mindset. And it is harder to achieve if you build it from an automation perspective.
Right, guys. I think we are at the end. So thank you, Patrick. Thanks, Gabe. I will just add at the end that on the 11th of September, we've released Fundamental Super Series, and I will plug the link to the description of that. And if you guys want to take a look more at Fundamental and how the frame is structured, you just need to watch it.
Thanks a lot for the opportunity, Martin.
You're welcome. That was a pleasure. Okay, Patrick, Gabe, thank you very much, and we'll see you soon.